chapter we will discuss the metal restoration fabrication and in both techniques, the traditional and the digital, some of the metal results and their causes with the metal finishing process. This technique has been introduced to the dentistry by the 19th century, although it was a common thing from the Bronze Age. It is about doing a wax pattern, then casting it to a metal product, where we surround the wax pattern with a mold made of heat-resistant investment material. Then we eliminate the wax by heating and introduce it into the mold through a channel called the sprue. This sprue can be made of wax, this is it, or plastic or metal. The wax is the most preferred and the most used because it melts with the wax of the restoration, and they are both escape from wax. Sprues are the most preferred and the most used because they melt with the same rate as the pattern, and they allow easy access of the molten wax. As for the plastic, because they have high temperature than the wax, they may block the escape of the wax and increase the casting roughness. But when we have several pieces that we will cast together as one piece, adding the plastic sprue will increase the rigidity and minimize the distortion. They can be hollowed to allow the escape of the wax. As for the metal, it should be made of non-corroding to avoid possible contamination of the casting. They are usually separated from the investment at the same time as the crucible former is. So this is the sprues, the wax and the plastics. They are usually attached to the bulkiest cusp. An additional sprue can be added to help gas escape. This bulginess is to control the flow and temperature of the melting material. It is attached to the silicone or plastic ring. So we first attach the sprue to the bulkiest cusp. Then we remove the pattern from the die. Then we position the pattern on the crucible former and apply a surfactant to decrease the surface tension. Then we add a ring liner to increase the setting expansion by stabilizing it with a sticky wax. It must be positioned in a sufficient distance that there is a minimum 6 mm distance from the border of the crucible. There is an FDI alloy classification that you can read or get information about. Now for the investing, we do is that we add the precisely measured liquid to the investment powder, and we insert it to the vacuum mixer, and then it is mixed thoroughly. We first coat the internal surface of the wax, and then we coat it entirely. Then we pour the remaining material inside the crucible until it reaches the level of it. We do some movement and tiltation to provide any air trapping inside the pattern. We leave it to set for 1 hour and remove the rubber crucible former. We heat the furnace for 200 C and hold this temperature for 30 minutes. Most of the wax is by then eliminated. Then we increase the heat for 650 or 480 for 45% minutes. The mold now is ready for the casting. Now for the casting, where we melt the alloy and insert it inside the mold. There is several methods to get the heat source. One of them is the induction casting of a copper induction coil that serves as the heat source, which surrounds the crucible, and the alloy is inserted in the crucible. Then it's initiated. There is the casting pressure is sustained by the electric motor in the base. It switches off automatically after 30 seconds, at which time the lid is unlatched automatically and the process is completed. In the traditional way, the crucible is preheated, as we said before, the first 30 minutes, then 45 minutes. The alloy is melted. When the alloy is molten, the casting ring is removed from the furnace and placed in the cradle. Then we slide the crucible platform into contact with the casting ring. The orifice of the crucible aligns with the sprue, and heating continues for a few seconds so that the melting is complete and casting can proceed. Then here, the casting arm is pulled forward until the pin drops. Then a central fugal force carries the melted alloy into the mold cavity. After that, it is cooled in water and it is opened out to get the casting inside. One of the common causes of failures, for example, if we got a rough casting, it is due to excess surfactant or an improper water to powder ratio or excessive burnout temperature. If we had large nodule, it is an air trapped during the investing procedure. If we have multiple nodules, it is an inadequate vacuum during investing, and it can be removed by burr. If we got the fins, it is caused by dropped mold. If you got an incomplete casting, it is an incomplete wax elimination. This is it. The fins are caused by cracks in the investment that have been filled with molten metal. And this is the removal of the nodules to ensure proper setting of the metal on metal finishing. We can use a liquid marking agent that can show us the internal surface nodules, so we can remove them by a rounded burr, small one, and then we trim the sprue and remove it from the teeth, the casted one, using discs and stones. And then we examine the proximal contacts using an articulating film and remove any excess. Then if we have multiple units that are connected with each other, we do a polishing for the connectors from both sides. Then we see the occlusion, and we remove any high contacts using a carbide burr or a pointed diamond one, but we must make sure that we do not exceed removal, and we can do this by measuring the thickness using this tool, and we can go no less than 1 millimeter. If we go less than this, we get an inadequate metal thickness that will make it fragile and cannot sustain the occlusal forces. Then we do the final polishing and finishing to get the final results. Now for the digital workflow using the CAD/CAM technology, it starts up by an intraoral scan of the tooth or a laboratory scan of the pre-treatment stone cast. We first margin trace, then we determine the insertion direction, then we do a virtual die spacer that corresponds to the cement thickness. Then from a library we can get an anatomic contour design, or if we did an impression before the preparation, we can get the exact shape of the tooth inserted to the program and be the design shaped morphology. If we want to make a metal restoration with a ceramic buccal surface, we do what is called a cut back, where we define the margin of the metal and the ceramic. We designed it in a couple of ways. The first one is by shrinking the digital created complete contour restoration by a specific dimension, or we can do it by shrinking specific areas while leaving other areas alone. And this is the cutback. We can manually adjust the size, the height, the occlusal contact points, and the thickness of the design. We can use virtual tools, the milling, the carving. At the end, the file is transferred to an STL file and it is exported to be used in the CAM machinery. There are two types of the manufacturing, the subtractive and the additive. The subtractive machinery is using a bulk material that is machined or cut away in a controlled process until the desired final shape is attained. This material can be a metal, ceramic, or composite. The metal usually is a cobalt, chromium, and titanium alloys. This is the subtractive or the milling machine. The other way is the additive, using a selective laser melting, where it is composed of three basic components: a movable build plate, platform, powerful laser, and a powder bed. The laser forms a part by localized melting of the powder. Then this platform moves down to a new position, and then a layer is added where the laser melts the powder metal. Then the process is repeated layer by layer, and each layer is only 30 to 50 micrometer until we get to the full thickness. When we want to veneer the metal restoration, which means that we do a buccal ceramic surface, we can do it by hand layering or by waxing and pressing, which is the press over metal technique. It is important in this type of restoration to have a physical model to get an ideal tooth morphology and occlusion on the ceramic part. But when we are doing it only ceramic, we can do it without any physical mold. So if we are having a conventional impression, we can then get the mold by casting, or if we did an intraoral scanner, we can get the cast by a 3D printed resin cast, and they are both have an accuracy of the dimensions. The chrome cobalt alloy is the most common used for the CAD/CAM fabrication metal ceramic restoration.